When you think of an atom, what do you imagine? Electrons whizzing around the nucleus like little planets are orbiting the sun? Well, brace yourself, because that's a lie. You've been lied to about atoms. This common image of an atom might make it easier to understand, but that's nowhere near close to the truth. In fact, the reality of how atoms work is even more mind-blowing. For a long time, scientists used what we call the Bohr model to explain atoms. According to this model, electrons orbit the nucleus in neat circles, much like planets around the sun. But as useful as this image is and how simple it may be, it's also kind of wrong. And here's why. Electrons don't actually have fixed paths around the nucleus. In reality, electrons exist in what we call orbitals. These aren't paths, they're more like clouds, regions that there's a high chance of finding an electron. The exact position and path of an electron can't be determined with any certainty. This is where quantum mechanics comes in. In the early 20th century, scientists like Heisenberg and Schrödinger realized that atoms don't work the way we thought. They discovered that electrons are best understood as waves of probability. According to the Heisenberg uncertainty principle, you can't know both the position and the momentum of an electron at the same time. So, instead of thinking of an electron's path, think of it as an existing probability cloud. That cloud shows the most likely places where you might find an electron, but never where. These probability clouds have shapes that depend on the energy levels of the electrons. Scientists refer to these shapes as orbitals, and they're far from simple. Some orbitals are spherical, but others may be shapes like dumbbells and have even more complex forms. Each shape represents different possibilities of where electrons might be. So, while we might picture electrons as little balls in specific orbits, they're actually behaving more like waves spread out over space, creating complex shapes that reflect the probabilities of being found. So, if this is wrong, why did we stick with this? Well, the Bohr model is simple, and for basic chemistry, it works well. It gives us an easy way to picture electron behavior. But once you deep dive into more modern physics, the Bohr model breaks down really easily, and we need quantum mechanics to describe what's really going on. The truth is that atoms and everything made of atoms are governed by strange, counterintuitive rules of the quantum world. Electrons aren't just little particles zooming around, they're better described as existing in multiple places in a wave like state that only collapses to a specific location when observed. It's a bizarre and fascinating reality that reminds us that nature doesn't have to fit neatly into our everyday experience. Quantum mechanics reveals that the microscopic world plays by a different set of rules. So, the next time someone tells you that electrons orbit the nucleus, you'll know the truth. Atoms aren't just simple, predictable systems that we once thought of. They're actually really complex and mind-bendingly weird. If this sounds wild, there's so much more to explore in the quantum world. Don't miss out on our next dive into the mysteries of the universe. Subscribe and keep learning with us at CNR Learning. Thank you.